In this lesson on functions, we're going to talk about what a function is and different ways you can represent a function. So we'll start with just a formal definition of a function. So a function is a rule that assigns each element x, which we'll call our input from a set A unique element f at x, which we'll call our output, and this comes from set B. So one way to sort of see what this means is to think about it as a picture. So we'll have two sets. So the first set we'll call set A, and the second set we'll call set B. Set A is usually referred to as the domain, and set B is usually referred to as the range. So from the domain we're going to get our first element. We're going to get this element x. So everything in A is our elements, and sort of a general one will be called x. This could be a number. Usually in mathematics it's a number, but it could really be anything. So what f is going to do is it's going to give us a rule for assigning this element to some other element here. So f, the function, is just whatever that rule is, which takes us from x to some other element in B, which we'll call f at x. Okay, so this rule here, whatever that rule is, that's the function. One thing which will become very important later on is this idea of it being a unique element, and all that means is x can only go to one thing in B. Right? So whatever your rule is, it can only go to one thing. Your rule couldn't take you to two different things, and we'll see more what we mean in a minute. Another just sort of terminology thing we might want to talk about right now. So we have this idea of the first set we call our domain, and the second one we call our range. The variables here we're going to call our independent variables. And the variables over here we're going to call our dependent variables. Okay, so the way I've represented this is what we call a mapping diagram. So a mapping diagram, you draw your two sets and you show sort of the rule. This was just a general mapping diagram where with no specific values or elements in our sets. But we could represent a specific function using a mapping diagram, so that's what I'm going to do right now. So this function is going to have a domain over here, which we'll call A. Set A. You don't have to call it A, but we'll call it A. And I'm going to have 4 elements, and those elements are going to be the numbers 1, 2, 3, and 4. And my range, or set B, it's going to have, I don't know, 3 elements, so I'll have the numbers -1, 0, and 1. Now, my function is going to tell me which values here, or which values here these ones are going to go to. So it'll tell me 1 should go to -1. That's my rule. So my function takes me from 1 to -1. Takes me from 2 to 0. Takes me from 3, also goes to 0. And 4 goes to 1. So these arrows kind of represent my function. So they tell me which values I'm going to. One thing just to be careful about, notice that each element here is going to a unique one over here. So what that means is 1 can only go to -1, 2 can only go to 0, 3 only to 0 also, and 4 only to 1. So these numbers aren't going to two different things. Something that throws people off a little bit sometimes is the fact that 2 is going to 0 and 3 is going to 0, but the point is that 2 is only going to one thing, right? 2 doesn't also go to a different number, so that's what makes this a function. So this is represented as a mapping diagram. Another way to do it, represent by listing listing the rule for each input in function notation. So there was only 4 inputs. So I could sort of represent what happens, what each input does, just by writing it down using function notation. And function notation just means this thing right here, the f at x, where we'll interchange each value for x. So for example, f at 1. So 1 is my input, or my independent variable, or the value for my domain. So that's this one here. What does 1 go to? It went to -1. So this would mean that f takes 1 to -1. The way we read this is we say f of 1 is -1. And then I would just list all the other values. So f at 2, what did 2 go to? Well, from my arrows up here, my mapping diagram, I know it goes to 0. F at 3, from my arrows up here, I know that also went to 0. And f at 4 went to 1. Okay, so I've represented the function another way, just by listing all the sort of listing the rule for each input using what we call in function notation. Should have that there. A third way to represent it, represent as a table, or a table of values, you could call it. So as a table of values, what you're going to have is 2 columns. The first column is usually your independent variable, or the variables from your domain, and the second column is your dependent variable. So you would just list all the independent variables under x. So 1, 2, 3, 4, and then in the second column just list the corresponding f at x value. So f at 1 was -1. So 1 went to -1. 2 went to 0, 3 went to 0, and 4 went to 1. So same function, just represent it as a table of values. A fourth way to do it is to represent as a set of ordered pairs. So as a set of ordered pairs, what we're going to do is we're going to write a set. So set notation, we'll write sort of a squiggly bracket, and then ordered pairs means a combination of 2 numbers. Now, the ordered pair, usually, always, the first number in your ordered pair will be your independent variable. So independent. Oops. Or your x variable, if you want to think of it. And your second one will be your dependent variable. So 1 goes with -1. 2 goes with, from over here, 0. 3 goes with 0. And 4 goes with 1. So I have these 4 ordered pairs in our function. Same function as was represented up here. So that's a fourth way to represent a function. We can also represent as a graph. So the graph is basically just these four ordered pairs put onto a graph. So usually always we're going to have a horizontal and a vertical axis. The horizontal axis will be our independent variable x, or our domain, and the dependent variable will be, the vertical axis will be our dependent variable f of x. So I just need to put these 4 points onto my plane here. So, the graph of f is the set of basically all these points up here. So generally we could write that like this. So it's the set of all the points, x, f at x. So that's just all these points where x is in your domain. So basically, it's just saying this is just the set that we wrote up here. So I need to make an appropriate scale for my x axis. So my x variables were just 1, 2, 3, 4. So that's all I need. 1, 2, 3, 4. And my y-axis, or my f at x axis, is I need 1, 0, and -1. So I need to put the point 1, -1. So 1, -1. So there's one of my points. 2, 0. There's a second point. 3, 0. And 4, 1. So these 4 points make up the graph of my function. So these are what we go through 5 ways. 5 ways, right? We had a mapping diagram. We had listing all the points. We had a table of values. We had as a set of ordered pairs, or we had the graph. So there's 5 ways that we looked at representing a function.